In two of the previous videos, we've seen how we can join tables together in SQL by having multiple tables in the from clause and then having the appropriate number of join conditions in the where clause. That works for most types of problems, but there are others in which we need to perform a special type of join known as an outer join. For example, let's say we're working with our university database and we want to pair each course with the name of the room in which that course meets. Now in the course table, we don't have the room name, we only have the room ID, and so we have to join this course table with the room table so that we can get the name of the room. Now what makes this job a little bit trickier is we also want to be able to handle cases in which a course does not have a room because it's an online only course. So those courses should also appear in the result of the query. So if a course does have a room, so for example CS105, its room ID is 4000, and if we go over here that means that it meets in GCB 204. So that row should be in the result of the query, along with a row for every course that does have a room. So CS111, room ID 5000, that means it meets in CAS 314, etc. Right? So we have 5 rows in the result for courses that do have a room, but we also want an additional row for PH101. It does not have a room, but that means that in the result we want it to be paired with a value of null, indicating that there is no room for that course. And that's what makes this tricky. So it might seem like we could do a standard join query. So we put both course and room in the from clause. That means we need a join condition, and the join condition is that the value of room ID from course has to match the value of ID from room. And you'll notice that in the select clause we have to prepend the name of the table so that we can disambiguate which name column we are referring to. To execute this, we would start by getting the full Cartesian product of those two tables. That's going to give us 42 rows in all. Next, we apply the join condition, and it narrows things down to rows from the Cartesian product in which room ID matches ID. And so that's going to give us these 5 rows. Finally, we apply the select clause, and we end up with just the course name column and the room name column from the rows that survived the join condition. And so this gives us most of what we want. But if you look closely, you'll see that PH101, the course that does not have a room, doesn't make it into this result. And that's because there is no row in the room table that matches this room ID. And therefore, when we look at the Cartesian product and we're looking for rows in which the room ID is the same as the ID, there is no such row involving PH101. So that last row of the course table is an unmatched row. It doesn't have a corresponding row in the room table, and therefore it's not going to make it into the result of a standard join. To get it, we need to be able to do something called an outer join, and that's what we're going to look at now. So let's focus on how our query needs to change. Instead of just having the two tables in the from clause separated by a comma, we're going to separate them with an operator, which is the left outer join operator. So one of the tables goes on the left-hand side, one goes on the right-hand side of those keywords, left outer join. And if you're doing an outer join, your join condition can't be in the where clause. It has to go in a special on clause. So I'm saying this is the join condition that you're going to use for this left outer join. And so it's no longer in the where clause, which means we now have an empty where clause. Now in theory there could be other things that go in the where clause, but in this case there aren't any, and so therefore the where clause goes away and the semicolon goes after the on clause. So at this point we're telling SQL we want to do a left outer join based on this join condition. And again, there are these two tables. The one that's on the left-hand side of the left outer join operator is the left table. The one on the right-hand side is the right table. So we're going to use those terms. And what the left outer join is going to do is find any rows from the left table that don't have a match in the join and include them in the result as well. So what does that mean? Well, we're going to start with the full Cartesian product again. We're then going to do a regular join based on the join condition. Again, the join condition is now in this on clause. That's going to give us the same 5 rows as before. But now, because we're doing a left outer join, we're going to end up taking any row from the left table, which in this case is the course table, any row that did not end up making it into the result of the join. And so in this case, it's just this row, the one for pH 101, and we're going to add an extra row to the result for that unmatched row from the left-hand side. If there were other unmatched rows, they would be added into the result as well. Now the question is, what are we going to put for the attributes from the right table? Since there wasn't a match, we don't have values there, and so SQL puts in null values. So this now is the full result of the left outer join. In addition to the 5 rows we got before with a regular join, we have this extra row for the unmatched row from the course table. Then we do the select clause. Again, we're getting course name and room name, and you can see we now do have something in there for pH 101 indicating that it does not have a room. Now, importantly, this null value is not the one that came from the course table. It's the one that is in the room name column in the left outer join. And so now we've succeeded in getting what we want. Every course name is paired with a room name if the course does have a room. If a course doesn't have a room, its name is paired with null. And this result is only possible using a left outer join.